Okay, so today we're going to start learning about the first steps of factoring polynomials, and that first step is the GCF. So the greatest common factor is the largest monomial that can divide a polynomial. The largest monomial that can divide a polynomial. Sorry about that. So, if we look at this example, what is the greatest common factor of the terms 12x to the fifth, 8x to the fourth, minus 6x cubed? We're looking for the largest number that can divide 12, 8, and 6. Which, if they're all even, so that's pretty easy, our greatest common factor is going to be 2. And then we're also looking for the largest number of variables, so here x, that is in each of them. So the easiest way to do that is find the lowest exponent. So our lowest exponent out of 5, 4, and 3 is x cubed. Okay. So we have another method that we can find the GCF, and that is factor everything out. So we know 12 could be multiplied to be, so we take this 12x to the fifth. 12 is 4 times 3, so I'm going to put the 3 times, and then 4 is 2 times 2, and then we have 5 x's. Okay. And you're going to do that same thing for each term. So now I'm looking at 8x to the fourth. Okay. So 8 is 2 times 2 times 2. And then 4 x's. And then we have negative 6x cubed, which is going to be a negative 1 times 2 times 3. And then 3 x's. And we're looking for what all three of those have in common. So if we look at that, we see each one has a 2 written once. And then we have 3 sets of x's. So that's a more visual way of seeing how we got 2x cubed as our GCF. Okay. So the key thing is you're looking for the largest number that divides everything, and then you're looking for the lowest exponent. Okay, so if we want to find the GCF of the terms of each polynomial, our first one we have 15x squared plus 18. So our GCF here, so 15 and 18 are both divisible by 3. And then we're looking for the lowest exponent. So here you have to be careful. So 18 doesn't have an x, so our GCF can't have an x. So that's it. The answer is 3. Sorry about that. Let's see here. Let's lock that. Okay. So on B, we have negative 18y to the fourth plus 6y cubed plus 24y squared. So whenever you have a negative in front, your GCF is going to be negative. Okay, so I'm going to go ahead and start off by putting that negative. Then, what's the largest number that divides 18, 6, and 24? And that would be 6. And then pick your lowest exponent, so y squared. And there's our solution. Okay, so now that we know how to find our greatest common factor, we're going to factor it out. So when we're factoring, it's very similar to division of polynomials. Okay, remember when we divide, we subtract our exponents. Okay, so if we look at this first example, negative 12x cubed plus 18x squared minus 27x. So remember I said for our GCF, whatever number's in front, if it's a negative, our GCF is negative. And now we're looking, okay, what's the largest number that divides 12, 18, and 27, which would be 3. And then our lowest exponent right here is a 1. So x to the first. Okay, so that's what we did up above, nothing different. So now, in order to factor it, you're going to write that out front. You have to write it out front. Without it, it doesn't say an equal expression. And then you're dividing. So what is negative 12 divided by negative 3? 4. X cubed divided by x. Remember, you're subtracting your exponent. So 3 minus 1 is 2. And then move on to the next term. So 18 divided by negative 3 is a negative 6. And then x squared divided by x, 2 minus 1 is 1. And then lastly, negative 27 divided by negative 3 gives us a plus 9. And then x divided by x is none. And this is your solution. Okay. So let's go to the right and let's do D. So here we have x cubed plus 5x squared minus 22x. So remember, this number in front is a 1. So the only number that divides 1 is 1. So here we're really just looking at our variables, but I'm going to go ahead and write that 1. So the lowest exponent on our variables is this last one, which is x. And then divide it out. So 1x is going to go out front. 1x cubed divided by 1x. 3 minus the 1 is x squared. Plus 5. X squared divided by x to the first is just x, because 2 minus 1 is 1. Minus 22, and our x's are all gone. Okay, so let's make it a little more difficult with slightly bigger numbers. So looking at B, we have negative 16y to the 6th plus 28y to the 4th minus 20y cubed. So here I'm going to go ahead and I'm not going to write this top step. That's not necessary unless it asks specifically for what is the GCF. So if we look at this, we have negative 16 in front, so we know our GCF is going to be negative. And then we're looking, what's the largest number that divides 16, 28, and 20? And that number would be 4. And then pick the lowest exponent of your variables, so y cubed. And then divide. Negative 16 divided by negative 4 is a positive 4. Y to the 6th divided by y cubed is y cubed. 28 divided by negative 4 is going to be a negative 7. And y to the 4th divided by y is y. And lastly, negative 20y cubed divided by negative 4y cubed is a positive 5. Okay. And E, going to the right. Now we have two variables. That doesn't change our process at all. So we have 16xy squared plus 4x squared y plus 8xy. So 16, 4, and 8 are all divisible by 4. And then pick your lowest exponents. So we have for x, I'm going to go ahead and put 1s over all these. So our lowest number of x's is just 1. And then our lowest number of y's is just y. So 4xy is our GCF. And then we divide. So break this one apart. So 16 divided by 4 is 4. X divided by x, those go away because they cancel each other out. And y squared divided by y is y. Okay, second term, 4 divided by 4 cancels. So I'm going to go ahead and just put a 1 there. X squared divided by x leaves us 1x. And then y divided by y goes away. Then lastly, 8xy divided by 4xy. 8 divided by 4 is 2. You had 1 x, you took 1 away, so you have none left. And then the same thing with your y's. You had 1, you took 1 away, you have none left. Okay, and our last one, C. Sorry about that. So C, we have 6x squared y squared plus 18xy plus 15x. So our largest number that divides 6, 18, and 15 is 3. Our lowest number of x's is 1. And then here's where you have to be careful. Does every term have a y? No, because there's no y written here. So 3x is our only common variable. So now divide. So 6 divided by 3 is 2. X squared divided by x, 2 minus 1 is 1. And then we don't have any y's to take away, so it stays y squared. 18 divided by 3 is 6. X to the first divided by x, they cancel. And then we're left with a y. And then lastly, 15x divided by 3x is 5. And there's your factored form. Okay, the last part we're going to look at is the areas of rectangles. So this is the exact same as what we just did with factoring out the greatest common factor. We're just going to do a more visual method of it in terms of an area. Remember, area is length times width. So if we find that this side right here, this is our common side, which would be our width of our rectangle. So we're going to find what is the greatest common factor of 9xy squared and 12x squared y cubed. And that's going to tell us our width of our whole rectangle. So 9 and 12 are divisible by 3. Our lowest exponent on the x is our 1. And the lowest exponent on our y's is y squared. Okay. Then we're going to find our length of each one. So we're going to divide. So 9 divided by 3 is 3. And then xy squared will all cancel. Then our longer rectangle, 12 divided by 3 is 4. X squared divided by x is just x. And y cubed divided by y squared is y. Okay. And if you're looking for the whole length, which would be this, we would simply add the two rectangles together with a plus sign. Okay. And then lastly, if we want to find the length and the width of our area of 6x squared minus 18x, I'm going to say our GCF is going to be our width again. So I'm going to find this part first. So 6x squared minus 18x, those are each divisible by 6, and our lowest exponent is a 1. So our GCF is 6x. And then divide. So 6x squared divided by 6x is x, minus, and 18 divided by 6 is 3. And those x's will cancel. And that is using the greatest common factor. If you ever want to check your answers, the opposite operation from division is multiplication. So we can always distribute and see if we got back our original. Thank you.